As we saw before, we have some techniques to find the limits. But what happened if the series if a sequence, is a little bit complicated? To solve this problem, we have some converging tests: the root test and the ratio test. Root test and ratio test works in many cases when other techniques that we saw before are failed, like we can factor anything or we can multiply by conjugate. It's not an Euler theorem. Those tests will tell us either the sequence is converging, either not. So let's start with the first test. It's called the ratio test. We will use ratio test, of course, if other techniques fail, but mostly when we see factorial things with factorials, because we don't know many techniques with factorials. If you have factorials, a lot of n power, things like this, like factorial of n, 4 in the power of n divided by something with factorials, things like this. This will give us a big clue to use ratio test. What ratio test tell us? If we have a sequence an, and from 1 to infinity, and we want to test its converging, we can do the next limit. We calculate the ratio limit. It's the ratio of a over n plus 1, a sub n plus 1, divided by a sub 1, and we find out what is the limit of this new limit. We want to find a limit of, what is the limit of an equals some, I don't know. And in order to find it, we are doing another new limit. It's a ratio test. So we can see it's a ratio between a sub n plus 1 divided by a sub n. And the ratio rule test says this: if L is bigger than 1, it means that the sequence is diverging and its limit equals infinity. If L is equal to 1, it means that this test is not powerful enough to give us an answer. It's unknown situation and we have to pick another test. So this test doesn't help us, so we have to think in other ways what to do. If L is less than 1, then our original sequence is converging to 0. So let's write it again. If L is equal to 1, limit of n approaches infinity of an is still unknown. We have to do other techniques. If L is bigger than 1, it means that the limit of our sequence reaches infinity, diverge. And if L is smaller than 1, then it means that limit of our sequence exists and it's 0. It's not something else, it's 0. Converge to 0. It's not just converged to something, it's converged only to 0. It's a very powerful and super easy test. Now you will see it's very easy to understand when I have to use this test. So let's start with the basic examples. Okay, so this is the ratio test. Let's start doing some exercises. Let's say we have the following sequence: limit of n goes to infinity of 4 in the power of n divided by n factorial, factorial of n. When I see factorial, I start to think about ratio test, because we don't have any algebraic operations with factorials, so it may be a ratio test. First of all, we plug infinity. We got infinity divided by infinity factorial. Of course, it's a very big infinity. So this is infinity divided by infinity. So we try to do a ratio test. We're calculating another limit of the ratio between the next number in the series divided by the present number. an plus 1 divided by an. We will get 4 in the power of n plus 1 divided by n plus 1 factorial. I just plugged n plus 1 instead of n. This is what I got. Divided by the original one, an. an is the original, an plus 1. I'm just plugging n plus 1 instead of n. 4 in the power of n divided by n factorial. We switch this. We know this rule. And we got 4n plus 1 multiplied by n factorial of n factorial divided by this. This is what we got. Now let's cancel things. We know that n plus 1 factorial, let's write it here, it can be it's very useful here. It's n factorial multiplied by n plus 1. Anyway, factorial of 3, it's 1 times 4, 1 times 2 times 3. It's multiplication from 1 till the number that's written in the factorial. Of course, 1 factorial and 0 factorial, by definition, it's 1. We can cancel this and we're leaving with 4. This I can write as n factorial multiplied by n plus 1, so we can cancel this. And what will remain here is 4 divided by n plus 1. Of course, the limit of this while n reaches infinity is 0. So what we see, if this limit less than 1, in this case it equals to 0. Then it means that the limit of the original series, is 0. I'm sorry, it's not that correct because it's not equals to L. What equals to L is this weird limit. This weird limit is equal to 0. 0 is less than 1. That means that the original limit is also equals to 0. Pay attention that they don't have to be the same. The number of this ratio has to be less than 1. It can be half, 1/3, I don't know, 0.29, I don't know. If it's smaller than 1, the answer of this series, of the sequence, is 0. Very easy. It's very easy rule. It's very easy to use. So let's do another ratio test exercises. Let's take this one limit of n approaches infinity of n factorial squared divided by 2n factorial. Many factorials. When I see factorials, I'm sure at 100% this is the ratio test. It can be anything else because I don't have techniques to deal with factorials. But first, I'll just plug infinity to myself to be sure that it's not a number. It's infinity in squared, it's infinity divided by infinity. Pay attention that don't always go to some test, because if, let's say, you have things like this, 1 divided by infinity is 0, and you don't have to make any test here. And in some cases, if you're wrong, the test can give you L equals 1. Which means that the limit is unknown with this specific test. But actually it was simple exercise, like 1 divided by it's 0. In this case, if you do the ratio test, you can get L equals 1. So if you don't pay attention, you pay. You pay in a grade, and it's not good. Okay, so what we're doing here, we're just doing the ratio test. Limit of n goes to infinity of, we're just plugging a sub n plus 1 divided by a sub n. It's going to be n plus 1 factorial squared divided by 2 times n plus 1 factorial. And instead of dividing it, I just multiply it by the opposite. It's some sort of a shortcut. And now let's open this very carefully. What is n plus 1 factorial? It will be n factorial times n plus 1 squared. So I'll write everything here in square. Multiple by 2n factorial divided by, let's take this expression here outside, it will be 2n plus 2 factorial, which means it's 2n factorial, multiple by 2n plus 1 and 2n plus 2. Write it down here, it will be 2n factorial multiplied by 2n plus 1 and 2n plus 2. And we have here the n factorial square. This cancel this, they both canceling each other, and what's left is n plus 1 squared divided by, I'm sorry, it's 2 plus 2 here, divided by 2n plus 1 multiplied by 2n plus 2. What's left is to calculate this limit. Let's using the formula n plus 1 squared. We'll use this formula as we saw before. A plus b squared will equal to this. And we have n squared plus 2n plus 1 divided by, let's open the brackets, 2n times 2n will be 4n squared plus 2n multiplied by 2, it's 4n plus 2n, it's 6n. I sure you know how to do this. This is the reason I'm doing it a bit quickly. The limit of this is 1 over 4. I'll just factor n squared and I get 1/4. 1/4, 1 over 4 is smaller than 1. That means that the original limit is 0. That's it. Very easy. Let's look at the next example. Let's look at this example. Limit of n goes to infinity of n in power of n divided by n factorial. Of course, it will be infinity divided by infinity, because infinity in power of infinity is infinity, and infinity factorial is infinity. So we will apply here a ratio rule. We calculate the limit of n goes to infinity of n plus 1 in n plus 1 divided by n plus 1 factorial of n plus 1 multiplied by the opposite factorial of n divided by n in the power of n. We can cancel this thing, n factorial, and what we got is n plus 1 in the power of n plus 1 divided by n plus 1, this is the n plus 1, multiplied by n in the power of n. We can cancel this power and we get n plus 1 in the power of n dividing by n in the power of n. What do you think is the limit here? Can I say that I can say it's proportional to maybe n in the power of n dividing by n in the power of n? If I theoretically open it, if I know what n is, so it will be equal to the coefficients of the highest power will be equal to 1. Can I say this or not? I'm not expecting you, of course, to understand why, but the reason is very big wrong. You do this, you lose points in your test. If the power is also changing, it's different than if the power is a finite number like 2 or 3 or something else. So I can't do this. It's a very tricky limit. It can be in your test, so pay attention. If the teacher didn't show you this limit in the lectures, be sure that he will put it in your test, because he knows that many of the people will fail it and will write 1. It can be 1, I don't know, maybe it's 1, but it's not the way how to deal this. We can write it like this: n plus 1 divided by n, using the rule of powers. And now, if I plug infinity, we got 1 in the power of infinity. What is this? It's Euler's theorem, or Euler's limit. So please make attention not to make these mistakes. It's a very tricky mistake to say, of course the limit is 1. I want to tell you, it can be 1. I don't know, maybe the limit is also 1. But the reason it's 1, not because of the reason I just told you. It's because Euler gave me 1. It's e in the power of 0. So now let's find what the limit is. It's going to be n plus. We want to determine the limit of n goes to infinity of n plus 1 in the power of n. We can write it like this using our algebraic stuff we just saw. It's 1 plus. What is this? It's a pure Euler. It's e in the power of 1. What does it mean? It means that the ratio is bigger than 1. It means that our series is diverging and the limit equals to infinity. This was the ratio test. Now we're going to talk about the root test. In this video, we're going to talk about the root test. What root test tells us? We will use root test if we try to do some algebraic things and it didn't help us, or the ratio test didn't help us. We will understand that we have to use the root test if we see expressions of that type. Like sequence has an nth root of something, I don't know. But pay attention that the root here must be of nth type. Not square, not third. The number here is not finite number, it also goes to infinity. What does root test tell us? If we have a limit of nth root of something, the root test says it will be equal exactly to this limit, an plus 1 divided by n. It's not that I'm taking and doing another root like we saw in the ratio, another limit like we saw in the ratio test, and we're comparing it to 1 if it's bigger to 1, equals to 1, or smaller than 1. These roots are both equal. So it's like running a ratio test, and the answer of ratio test is exactly the root, the limit that I need. It's not, again, it's not that I'm comparing this root test to 1, bigger or smaller. Root test says to me that if you want to understand what is the limit of something of nth root, just do this simple ratio test. The answer of this ratio test is the exact limit of the sequence. Let's take something very basic. Limit of n reaches infinity of square root of n of n. Nth root of n. I recognize that we have root here. It's not a finite root. If we have something like this, it's not the square root, so don't make this mistake. It's like doing ratio test. We take the inner part, what's inside the root, and we just say it's n plus 1 divided by n, because we are doing this. The limit of this is 1. So what does it mean? That the limit of this sequence is also equals to 1. Very, very easy. Let's take another example. Limit of n goes to infinity of nth root 2 in the power of n plus 3 in the power of n. I'm recognizing nth root, so I'm doing this ratio limit. Pay attention, I didn't say ratio test because it's not actually a ratio test. It's some sort of ratio between a n plus 1 and a n. It's not ratio test. It's a ratio, regular ratio. So I'm taking the inner part here. Just a second, let's take another color. Taking inner part here and just plug n plus 1 everywhere I see n. N plus 1 plus 3 in the power n plus 1 dividing by 2 in the power of n plus 3 in the power of n. It's like doing what we got. It's actually, as we saw, an exponential fraction. What we said before, we have to factor the biggest base. It's 3. So we have here is 2 in the power n plus 1 divided by this plus 1. Here from the denominator I can factor 3 times n. Pay attention, I'm doing this a little bit quicker than before because we do this many times. What is this? And what is this? 2 n plus 1 divided by 3 n plus 1, I can write it as 2 times 2 plus n using power rules. 2 equals 2/3 multiplied by 2 over 3 in the power of n. This goes to 0. 2/3 multiple 0 is 0. So this goes to 0 and this also goes to 0 as we can see here. And we got 3 in the power of n plus 1 multiplied by 1 divided by 3 in the power of 1 multiplied by 1. This canceling each other and we got 3. So the limit of this sequence here is also 3. Pay attention, it's not infinity because 3 is bigger than 1. It's 3. Because root tests tell us that the both limits are the same. Let's look at another example. Limit of n goes to infinity of nth root of n factorial of n squared divided by 2n factorial. I don't remember if we did this before. I think we did this limit of the inside of the root before. I'll do this again. What we're doing here, the root test says that those limits are the same. 2n plus 1 squared. I think we did this limit before. Anyway, if we didn't do this, I'm leaving you to do this by yourself. This limit equals to 0. So what does it mean? It means that this original limit is equals to 0.